Everyone, welcome back to Enter Education. Let's continue with the reflection of light at curved surface. I've already explained the starting of the topic in my previous video. To understand everything in detail, please have a look at my previous video. So in this video, we're going to explain from page number 4, 5, 6, and 7. How can you search my videos on YouTube? To search my videos on YouTube, you simply have to write class 10, your chapter name, SCERT, your subject, which is physical science, by MJ Education. So this is mandatory, okay? By MJ Education -MM, and the page number for your convenience. So today we're going to continue with experiment 1.1.1. And it is on page number 4 in English medium, but if you're referring to Urdu or Telugu medium, it is on page number 8, and this is how your page looks like. So in this experiment, which is 1.1.1, it is about verifying your drawing with the experiment. Okay, firstly, why are we doing this experiment? We're doing this experiment to test curves in the mirror. We first need a beam of parallel rays. Look at figure 3. 2 pins in the thermocol block. When the candle is very close, the shadow of the pins spread. Move the candle away and the angle of divergence gets smaller. Angle of divergence means the angle with which they're spreading. Okay. If you move the candle a bit more far than that, okay, far away, the shadow becomes almost parallel, but the light turns dim. Okay, now this is a problem. We want parallel shadows, which we've got, but the light is turning dim. Now we want a source which is having the ability to produce parallel shadows and a brighter light. Can you think of one such source? Yes, it is the sun. Okay. Now this is done. On this page only we have activity 2. Okay. Here what you have to do is hold a concave mirror in sunlight. Okay, Here on activity 2, what you have to do is hold a concave mirror in the sunlight, take a small piece of paper and slowly move it in front of the mirror until you see the tiniest bright spot. That's sun's image. If you see in the picture, it's quite clear. No? But take a very small paper so it doesn't block the incoming rays. Okay. Now in figure 4, the sun rays are parallel to the principal axis. Okay. But after reflection from the concave mirror, they meet at one point, which is F. This is focus or focal point on the diagram. P, we've already studied. P is the pole which is center of the mirror surface, and C is the center of the curvature, that is the center of the sphere the mirror is a part of. F lies between principal axis and C, center of the curvature, as shown. Moving to page 5. Now, radius of the curvature is twice of the focal point or focus. Okay, this is what you need to remember. And center of the curvature is twice far away from the focal point. Okay. Now, moving to page 5 in English medium book or page 10 in Urdu medium, the radius of the curvature R is twice than its focus. So R is equal to 2F. This is what I've said in the previous slide also. Okay. So C is twice as far as mirror F. Okay. Now this is F. And if you could see, now you need to try this. Okay. Hold the paper closer than F. If it is closer, then slowly move it away. The sun's image first keep getting smaller. Okay. If you just put it closer to F, it gets smaller. And near F, it will be the smallest. Okay, and if you slowly start getting away from F, then it will be the biggest image. Okay, and beyond F, it starts getting bigger again. Now, one thing which I want to say you students is, note one thing, that this dashed line which is represented in the figure, those are non-reflecting sides. Okay, it is present, so it's only to for a clear perspective of you student. So it is clear which side is reflecting and which is not. Okay, now look at figure 5, the convex mirror. Parallel rays hit it and spread out, diverge. Okay, the parallel rays, the lines which are continuous, it is hitting it and then it is spreading out. Spreading out means it is diverging. If you extend this reflected rays backward, now you see this rays which is reflecting backward, which is a dotted line. Okay, they seem to meet at a point which is F. See, it is meeting at F. F is virtual, so it is only for presentation purpose, or it is imaginary, but it is not like in real. Okay, F is what? It is virtual. They seem to meet at a point behind the mirror. This is behind the mirror. That's F, focal length of focus for the convex mirror. Now, can you think an answer for figure 5? What can you say about convex mirror? If you put a paper at F, will you get a real spot? Think, will you get a real spot? No, because the rays don't actually meet there. Now, the important thing to remember is parallel rays in concave makes them meet at F, which is real, whereas in convex makes them diverge and only appears to come from F, which is also virtual. Okay, thank you. Now, turning to page number 6 in English medium book, or page 12 in Urdu medium or Telugu medium, and this is how your page looks like. So we're doing an activity over here, okay, the lab activity. But why are we doing this? Okay, the goal is to see what kind of image a concave mirror makes, and measure U, which is object distance, and V, which is image distance. So you will need a candle as shown in the figure. You're going to need a paper as a screen, and a concave mirror of known focal length, and a V stand to keep the mirror, and a meter scales. Meter scale is required over here. Okay, set it up like figure 6. Mirror on the stand at 0. Scale on the table. Candle on one side of the paper, and paper on the other. Keep the flame a little above the axis and the paper a little below, so the flame don't block its own image. Now, do the lab. Okay, place the candle at different distances, say 10, 20, 40 or 80 centimeter. For each U, what is U here again? It is object distance. From where to where is the object distance? From candle to mirror is the object distance. Okay, slide the paper until the image is sharp. Remember, U is what? It is candle to mirror distance, which is also known as object distance. And V is what? It is the distance from paper to mirror, which is also known as image distance. And you also need to check whether the image look enlarged, or is it diminished, is it inverted, or is it erect. Now, here you see focal length is 10 centimeter. Okay, and C is what? Center of curvature is 20. Okay, and this distance U is how? What's the distance? U is distance from mirror to the candle. V is the distance from mirror to the paper. Okay, now let's start filling. For 30, let us take 30, which is beyond C. Remember, always C. What is C? C is 30. If we are taking U as C is 20, if we are taking U as 30, so this is beyond C. Means it will come after 20. Okay, 20 is our center of curvature. So the distance of V, this distance will obviously get shorter, which is 15 centimeter. Now this 15 centimeter will fall between F and C, which is focal length and center of curvature. The image which will be formed is diminished and it will be inverted. I have written I, which means inverted. D means diminished. Second thing is we're going to take it at 20. 20 is what? C is, again, look at up. C is 20. The second one which we are taking, distance U is 20. So the V will also be 20 and image form will be of same size and it will be inverted. The third thing is we're going to take it at 15, which is from like before F and C. Okay, then the V is what? Image distance will be 30 and what will be the image? It will be enlarged and then again it will be inverted. At the shortest, which is 8 centimeter between mirror and the F, there is no sharp image. Image form, which it is formed, image is formed, but it is behind the mirror. Okay, and the image is enlarged. It is in the mirror. Okay, it is not reflecting on the paper or something like that. It's in the mirror only, and it is erect and it is virtual. So this, it is erect and it is virtual. So this table you need to remember and you need to keep it in your head. If possible, try to take a screenshot and fill it in the reader. Okay. In this, the pattern we notice is when the candle is far, if it is kept far beyond C, which is first one, okay, which is 30. The image is small, it is inverted and forms between F and C. Okay, bring it to C, at C, which is second one. C, if you see, C is 20 and then the second one which we took is 20 at C. Image is the same size and image is the same size at C. Now between C and F, image is big. Between C and F means again 15 centimeter we are taking. It is big and inverted. Okay, at F you won't get a screen image. The rays go parallel. Okay. Move the candle between the mirror and F and you will see an erect and large image which is virtual. So these things I've already written over here in the slide for clear understanding of you students, and if possible take a screenshot of this also and you will be having a clear perspective of what I am teaching you people. Now turning to page number 7 in English medium and page number 12 in Urdu medium or Telugu medium, and this is how your page looks like. Okay, after the candle and the paper lab, look into the mirror. So there in the previous table we were looking at the candle and the paper. Now here in this table which I'm going to represent now, here we are looking in the mirror or into the mirror. Okay, group your observation where the candle is, and here we also have to group our observation. Okay, between mirror and F, image forms is behind the mirror. It is enlarged, erected and virtual. You see it in the mirror and not on the paper. So these I'm just saying it verbally, and then I'll be filling the table for you students. At focal F, okay, there won't be any image on screen, and rays become parallel in the mirror. It looks highly enlarged or virtual. Between F and C, image form is behind C. Okay, it is enlarged, it is inverted, it is real, and you can catch it on the paper. At center of the curvature, image forms at C is of same size, it is inverted and real. Beyond C, image forms between F and C. It diminishes, it is inverted, real. Okay, so the main thing to remember is as the object moves far, okay, from far to near, the real image moves from near to far. I'll repeat it again. The object moves from far to near. The real image moves from near to far. Okay, keep this in your mind. Okay, and then it changes from diminishes to same image and then to enlarge and then stay inverted. How will the image change? First it will become diminished and it will become of same size, and then it will be enlarged and then it will be inverted. At F, the screen image disappears. Now let's start with the table. Between mirror and F, it is behind the mirror, as I've mentioned earlier. And then it will be enlarged, it will be erected, it will be virtual. At focal F, it will be at infinity and there won't be any image, and then the image which will be formed, it is highly enlarged because it is at f, it will be erected, and only in the mirror it is again virtual. Beyond C, like between F and C, the position of the image is beyond C. It will be enlarged, it will be inverted, and it will be real. Okay, at center of curvature, which is real. Okay, at center of curvature, at C. Okay, this is at C. The size will be same. The image will be inverted and it will be a real image. Beyond C, the image will be formed between F and C, which is focus and center of curvature. It will be diminished, it will be inverted, and it will be real. Okay. So this took effort to shoot, edit, and simplify. If it helps, like, so I know which topic to, cover next. Share it with your benchmate before lab and subscribe for the next page. No fluff, just the exact idea you need. Thank you.